Hello. In this lesson, we will focus on setting up lights in a scene, on the types of light sources and lighting schemes. We are going to talk about how you can use light to make your scene impressive. Light is an essential tool. A well-set light can make your render look beautiful, even if your scene is very simple and there is nothing special about it. For the 2D to 3D video, we use the popular photorealistic renderer, namely Redshift. This is one of the fastest renderers and is a great solution for small companies and independent artists. To complete the course, I recommend using the demo version, unless of course you already have a license. The demo is not limited in any way in terms of time and quality of rendering, except for watermarks. It will be quite enough to master the workflow and make an informed decision about buying a license. In this lesson, we will learn how to set the light in your scene. Properly set lighting makes your scene interesting and catchy, so it's important not to ignore it. What is good lighting? Lighting has to do two things, one of which is to convey the shape of the object. Remember, objects should not appear flat or blend in with the background. Here you can see some examples of poorly set lighting. In these cases, the light is facing the object, making it appear flat. The second task is to convey the atmosphere. And here you can see an example of how the artist perfectly coped with both tasks. In this case, the viewer feels the mood of the magic forest and the shape of the objects is clearly visible. For setting the lights, we will be using the tools from the Redshift Lights menu. Let's talk about the types of light sources first. Redshift Light gives us the ability to choose from several types. We have dome light, infinite light, area light, mesh light, IES light, and sunlight. Before moving on to lighting, we need to do some render settings. I will set GI, or global illumination, to the brute force mode. This is very important as it affects how the lighting in the scene is processed. The easiest way to light up your scene beautifully is with dome light. It is a spherical light source that illuminates the scene from all directions. For this, you need to have an HDR, or High Dynamic Range image. It is easy to download from hdrihaven.com or textures.com. Here you can see how a regular JPG image differs from an HDRI one. JPG is on the left and HDRI is on the right. You need to specify HDRI in the path field. We now have lighting for the cube. With a well-chosen HDRI map, there is often no need for additional light sources. I chose another map. You can see it here. We can also disable the display of the map using the Enable Background checkbox. So you can choose from studio light, soft evening light, or bright midday sun. This light can also be edited. It can be rotated, while the illuminated picture will change. And we can also edit the exposure parameter to decrease or increase the intensity of the light. One of the important advantages of this type of lighting is the ability to immediately place an object in a ready-made environment. Let's set up the render window so that we can see everything we're doing. To do this, drag it here with the right mouse button and release. You will find my favorite HDRIs in the package for this lesson. The next popular light source is area light. We can see its display in the viewport. This is not the final lighting, but an approximate one, so that you understand the direction of the source. We can also turn off the illumination in the preview illumination viewport. This source can be rotated, scaled, and moved. To make it easier to manage, I use the target tag from the Tags Animation Tags menu. Add this tag to the area light and specify the object you want to light in the target object field. Now the movement of the light source is parented to the position of this object. If we move and rotate our source, it will always be directed towards the illuminated object. In the render window, we can see the lighting that this source gives. Area lights are great because they give you the softest shadows and the softest lighting. The larger the area of the source, the softer the lighting effect. If we have enabled the Normalize Intensity checkbox. Otherwise, the intensity will increase as the size of the source increases. Now I have increased the source and the intensity has increased. It shines brighter. But if I press Normalize Intensity, we can see that now it barely shines, since the source is large and the intensity has remained the same. I will have to increase the intensity significantly to see the light. I will disable this checkbox and the intensity will increase incredibly. We will see a very bright light. You can turn this checkbox on or off. It's up to you. For this source, I would like to show one interesting parameter. Spread is responsible for the direction of the rays of this source. With it, we can make the light more diffused or more focused. I created a scene where the light from the source resembles a spotlight, and we can see a clear spot of light. But if we increase spread to 1, we will see how its outlines are blurred. Area light gives the most photorealistic result and is therefore the preferred source when lighting a 3D scene. Area lights are used in a 3-point lighting scheme. If you are interested in photography, you have probably heard of it. This is a good way to create an interesting silhouette and atmosphere. I have already created the scene. All that remains is to set the lighting. I chose this still life to show you a 3-point lighting scheme. Let's take a look at the first light source, which is key light. This is a source of small sizes with high intensity. The intensity or strength of the source is set by 2 parameters: intensity multiplier and exposure. My intensity multiplier is 5000 and exposure is 5. For us, these numbers are not very important, since these 2 indicators are multiplied. So use them the way that suits you, relying only on how the light looks. Let's take a look at its location. It is placed at 15 to 45 degrees from the camera, above and to the right of the illuminated object and slightly tilted. With it, we can create reflections and emphasize interesting details. Now let's take a look at fill light. It's used to uniformly illuminate the object to adjust strong shadows from the key light. Let's see how they look together. For the fill light, I checked the Normalize Intensity checkbox and increased the size of the source. The larger its size, the softer the light will be. A large light source gives soft, diffused light. A small one gives directional and contrasting light. We put this light on the other side of the key one, to the right of the object, but not symmetrically. Then the last, backlight, from above and behind the subject to separate it from the background and emphasize the shape. It also slopes slightly. This is what a 3-point lighting scheme looks like. Let's turn on all the sources in turn. The key light emphasized the details. The fill light helped us illuminate the scene. And the backlight separated the still life from the background. To see the final render, we need to enable the bucket rendering option. To make it easier to work with light, you can use clay mode to determine which areas need to be refined. Here you can clearly see which areas are lit and how much, so the material will not confuse you. There's also the sampling mode where we can see a noisy area as well. We can also choose a color for our area light. We have several modes: color, temperature, and color plus temperature. And I prefer to use the temperature mode as it gives a physically correct light. Low temperatures will give us warm reddish and yellowish tones, while high temperatures will give us a cool blue. I often use this setup. First, I illuminate the scene with dome light, and then I use a few additional soft diffuse area lights to further illuminate the desired areas. In this scene, I want to show the method that I use to light up the glass. Glass is the most difficult to illuminate, as its shape can only be shown through reflections. First, I put on the backlight and adjust it so that the shape of the glass with the candle is clearly legible. Then I put two lights on the left and right. On the left, a sharper key light, which creates a shadow, and on the right, a soft fill. And now I will put a light blocker. This cube will do just fine between the backlight and the candle to create an interesting soft shadow. Let's take a look at the light diagram. You see a large backlight. Between it and the glass, there is a light blocker cube. It creates an interesting shadow, but does not appear in the frame. The key light is on the left, the fill light is on the right. We put backlight first because it was important for us to define the shape of the glass. Then goes the key 1, and the last is the fill light that illuminated the scene. The sampling settings in the render ensure that the result is not noisy. In the new version, there's the automatic sampling parameter, and Redshift itself calculates the required number of samples, which saves us from having to solve this problem. If you have an earlier version of the Redshift, up to 3.0.13, and you got a noisy result when rendering glass, you need to increase the sampling of reflections and refractions in the glass material itself. I used this lighting scheme, dome light plus area light, in one of your homework assignments. In most cases, this is sufficient. Let's turn on these sources in turn and see how they interact. I used the Ennis map. You will find it in the package for this lesson. And also put an area light with a slight intensity on top. Do not try to add many sources as it may be difficult to manage them. At first, you can use only the dome light, which is enough in many cases. When illuminating objects, remember that the correct behavior of the light is primarily affected by the direction of the normals in the model. Select the polygons of the object and see what color they are marked with. They should be yellow. If they are blue, your normals are reversed. In this case, use the right click to get the context menu and click Reverse Normals. This is especially important if you are rendering glass or translucent objects. Also check to see if your polygons are overlapping each other. All of this affects the calculation of reflections and may not produce the image you want. I also want to draw your attention to this. For light sources, you can exclude objects in the scene from lighting in the Project tab. For this, simply drag and drop objects that you do not want to light into this field. For example, I will exclude the cherry from the lighting. Although this possibility exists, try to refrain from using it. When you exclude objects in the scene from lighting, you deprive yourself of the opportunity to achieve a physically correct, realistic result. The next source we'll talk about is point light, which is a point source that emits light evenly in all directions. I rarely use it. It can be used when you want to create candlelight, starlight, a small bulb, etc. It can be used to illuminate a scene as well, but I think it would be difficult to tune it in such a way as to get good light. The next is infinite light. It's used for exterior lighting, and it simulates an infinitely distant light source such as the sun. For this source, only its direction is important. The physical sun is a similar light source that simulates the sunlight passing through the Earth's atmosphere. It is often used in conjunction with Redshift Sky, which simulates the sky. The most convenient way is to use Redshift Sun and Sky Rig. It illuminates the scene from all angles like dome light, and its color is calculated based on the position of the sun. Thus, we can simulate any time of the day, which is very convenient when we want to illuminate the exterior. The next light source is portal light. It is used in rare cases when it is necessary to simulate light from a window or doorway in the interior and is a kind of window through which another light source enters. To show this, I created a cube construction with a window and lit the scene with dome light. The dome light does not light up the cube very well now, as it is hidden inside. I will create a portal light and set the environment shader to dome light. Thus, the portal light will be the portal through which the dome light passes. You won't be able to see portal light in the viewport unless you have another source outside the interior. We will also look at photometric light sources, IES lights. They are also called architectural because they accurately and physically correctly convey light, such as light bulbs, and are often used when rendering interiors. They have a complex structure, and so the light does not spread in a direct stream. Use them when you are interested in the light beam itself or the spot from it. They can also be used to make the background more expressive. Such sources are often used to transmit headlights or floodlights. Here are some examples. Let's create an IES light. In the path field, we need to specify a special IES profile. Here we see the display of the selected profile. You can download IES profiles on the internet for free. They are often found on the website of the lighting manufacturers. IES lights, in my opinion, also give us space for creative lighting. And finally, I want to cover the spotlight. I use it quite often. Spotlight is a directional light source that resembles the beam of a spotlight or flashlight. We can edit the light spot of this source by tweaking the cone angle and the fall-off angle and fall-off curve parameters. They affect how diffuse the spotlight is. It is often used with volumetric light, so-called volumetric beams. They are achieved by passing light through a cloud of gas, smoke, dust, or aerosol. To do this, you need to create a Redshift environment object. Then, in the Volume tab of a particular light source, increase the contribution scale. You got volumetric light. To influence it, go to the Volume Scattering tab in the Redshift environment. To get, for example, a translucent volumetric, reduce the scattering. Here I used an animated spotlight and the Redshift environment in combination to make it look like the cube is being chased. I also created a light on the right to make the cube seem to move towards the exit. The idea is to create tension and convey dynamics. I also like to use spotlight and Redshift environment to emphasize details. In this scene, I created a spot of light in the center of the composition above the plant to attract the viewer's attention. I also wanted to emphasize the droplets and the beautiful material of the leaves. With the redshift environment, we can also create fog and noise. To create fog, you need to select a color in the Volume Scattering tab, in the Fog Emission parameter. In my case, it is light turquoise. And control the Attenuation parameter in the redshift environment to make the fog thick. The fog will cover all visible space. Use the Use Transform option to move the redshift environment in the viewport and adjust the position of the fog. If you want to limit it, for example, use it only at the bottom of the scene, then use the Height parameter. Use the Blur Horizon parameter to blur the horizon line of the fog. You can also create noise. This is a very nice effect when we show fog on a certain texture. Much will depend on the size, intensity, and position of your light source. Here I have a shader assigned to Environment. In the Redshift Utilities tab, select the Noise Volume material and apply it to the environment. The only thing left to do is to adjust the noise. There are different types of noise here, as well as parameters that allow you to adjust them. Tweak the scattering and attenuation parameters until you get the picture you want. I also want to talk about this type of area light, like mesh light. You can turn it on here and drag an object that will emit light into this field. It is used when you want to show the shape of an object that emits light, such as when you render fluorescent lights or neon lights outside. In this scene, the neon tubes are made with a sweep, and I will place it in the mesh field. The visible option must also be enabled. Let's create a torus. Then create an area light and select the shape mesh. Let's move the torus to this field. Nothing is visible in the render now. Let's turn on the visible option to see the torus that emits light. We can also edit its intensity. Now let's say a few words about caustics. Caustics are light patterns on a surface that you may have observed at the bottom of a pool or shallow body of water, as well as when the beam passes through a lens or glass. To turn on caustics, you need to enable the Emit Caustic Photons parameter on the selected light source in the Photon tab. You can also adjust the intensity multiplier and number of photons to emit settings. If we go to the Advanced tab, we can see that caustics are enabled by default. Here's the Enable Caustics checkbox. Then put the redshift object tag in a caustic object. In my case, it's a diamond. And enable Override and Cast Caustic Photons checkboxes. Remember, caustics will only be visible when rendering in buckets. Here's the button. If you have progressive rendering enabled, you won't see caustics. Caustics must be used with Spotlight. I've turned on caustics on the Spotlight, which shines a directional light on the diamond from the scene we saw earlier. To achieve a good result for this kind of model, you need to find the good position of the sources. If you rotate the Spotlight, you will see how the caustic light patterns change. It will take some time to achieve the desired pattern. Also, using this scene as an example, I will tell you about a technique that will allow you to create and position a beautiful lens flare in the right place. To do this, use the lighting tool in the Cinema menu. Turn on the Spectacular Placement mode. Look from the camera and click at the position where you want the flare to happen. A light source appears in the scene. This is a cinema light source. Now create a narrow area light with a low intensity and parent it to the source that appears. and then reset the coordinates so that it fits in the right place. Now move the area light to the top and remove the source from Cinema. Let's set up our area light. You have an artistic reflection. One of the techniques I often use is light blockers, unmotivated shadows or objects positioned off-screen subject. They create a sense of intrigue and completeness of the scene, as well as create the right mood. This is a good way to make your render look more interesting. For example, in this Lego fried egg scene, I added a shadow on the top left, and it kind of expands the boundaries of my scene. Additionally, shadows can complement your composition if you feel like you need to balance the scene. In my case, without this shadow, the bottom of the composition would look overwhelmed, while the top left corner appears to be empty. With the help of a light blocker, I managed to achieve a finished scene. In this scene, I added a light blocker on the top right to create intrigue and expand the boundaries of the scene. I also have several sources of different colors. The bright light on the right, which resembles light from a window, and the one you can see from the top left, with a reddish tint, which is typical for artificial lighting. Such subtle details complement the scene very well. You can see another example of using light blockers here. Here I am using a light blocker on the water to make it look more interesting. Now let's see how you can light the scene from the 2D to 3D video. Here is a difficult object to illuminate, namely a diamond. First, I added a dome light with a low exposure, as my task was to illuminate the diamond from all sides to remove the black parts, but not to overexpose the scene, as otherwise the objects will look flat. Then there's key light, a harsh light on the left, that gives nice reflections, especially on the edges of the controller. Then there's the backlight that separates my scene from the background. And the last light is for the fish, which is a little further away from the rest of the objects. This is kicker light, a light that highlights specific areas. It is small and of medium intensity. Lastly, I added a soft fill light to the right to brighten the scene, especially the diamond, and blur the harsh shadows. We see that the shape of all objects is well readable. There are reflections. There are no dark areas. And the objects are separated from the background. Why do we have so many sources? When there are a lot of objects in the scene that need to be illuminated, we can use more sources than in the usual three-point scheme. And I want to share an interesting life hack. Look at the ring on the finger. I used a reflector to remove a sharp black spot on the metal and a sharp glare. This is the plane to which the glossy white material is assigned. Let's try turning it on and off to see the difference. Without reflector. Let's take another look at the scene lighting mistakes. Using too much light, example, overexposure makes it impossible for us to see the shape of an object, making it flat. This render could have looked much better if it weren't for the overexposure. Look at the overly bright white of the pieces and the bright reflections. Noisy areas. The new version of Redshift from 3.0.13 copes well with this. There was an auto-sampling parameter, which automatically determines the required number of rays. In case you have an earlier version, try the following. Increase the number of samples in the render settings. Use bucket rendering. Increase the sampling on the light source. Or select the override lights option. Or try to light up your object. If you are rendering glass, you can increase the sampling on reflection and refraction. Flat objects. When you see an image and involuntarily think that it reminds you of old games, it means there's a lighting problem. This often happens when the light is parallel to the camera and there are no shadows. Thus, the shape of the object is not readable. Look at the Lego bricks. It is difficult for us to understand their shape at first glance, and we need to look closely. To get rid of this, move the light source and tweak its position and tilt it. The illuminated object blends in with the background. Take a look at this can in the picture. It seems very difficult for you to understand its shape. This is because the dark can blends into the dark background. A large, soft light source from behind would visually illuminate it and separate it from the background. It's quite simple to fix. It is these little things that make the scene catchy. And the last mistake is to illuminate the scene evenly from everywhere. Firstly, it makes objects look flat, and secondly, they look boring. To avoid this, it is best not to place sources symmetrically, and they should not have the same intensity. As a homework assignment, I suggest you light two scenes. The first one is a close to realistic render. Your task is to make the light look like an advertisement photo. The second one is a stylized render. Since the scene is quite simple, your task will be to play with the light. You can add fog or noise, find the right position of the light. You can add various light sources like sun and sky rig, point lights, IES lights, add color to them, etc. For this render, the primary task will be to convey the mood and emotions. In my case, I tried to convey a mysterious atmosphere. If you want to recreate lighting schemes or look at them in more detail, you can find them in the supplementary materials for this lesson.